Hello, today I'm going to give a basic tour of AVID's Aircraft Synthesis Design Tool, or ACS. AVID ACS is tailored towards the conceptual and preliminary stages of aircraft design. Its extensive analysis capabilities allow for a broad range of aircraft to be designed and modeled. The ACS aerodynamics model is based on momentum theory and includes a viscous drag model for drag prediction. These methods have been validated against many analytical, wind tunnel, and flight test data sets. Other components of ACS include propulsion analysis, trajectory modeling, and weight prediction. ACS has been used to design and analyze numerous types of aircraft, including small UAVs, passenger and cargo transport aircraft, fighter jets, vertical and short takeoff and landing aircraft, high altitude, long endurance aircraft, supersonic jets, and general aviation airplanes. AVID ACS is supported on Windows, Mac, and Linux and works the same across all supported operating systems. During this brief demonstration, we'll cover what AVID ACS does, what various elements in the user interface do, and how to examine the output generated by AVID ACS. To begin, you can see the AVID ACS startup screen, which provides quick access to existing files and includes test cases that can be used as templates to learn about AVID ACS. I will select the Boeing 747-400 test case. It takes just a few seconds to run, and upon completion, the outputted results are automatically shown. The user interface is arranged to show program inputs on the left and program outputs on the right. In the top left of the user interface is a button showing the current ACS file being used. Clicking it will expose a drop-down menu listing of other open ACS files. It is possible to have several ACS files open at once, which will work independently of one another. Switching between files is simple. Just click on it on the drop-down menu that you want to use and the user interface will load it. Just below this is a similar button that will show or hide the workflow control section. Hiding it will collapse this section, exposing more of the text editor beneath it, which I will cover further in a moment. The workflow control section provides a quick representation of the control section in the editor. Clicking icons in the workflow control section will bring you to the corresponding section of the user interface. Clicking on a used input icon will scroll the editor down to the corresponding section. Likewise, clicking on the Use Output icon will change the right-hand side of the user interface to show the corresponding output. Just below the Workflow Control section is the text editor. Changes made in the editor are run automatically by ACS to regenerate output. The editor will be familiar to experienced ACS users, but it is also designed to support beginning ACS users. Due to the expansiveness of ACS capabilities and the large number of ACS variables, learning each variable's role can take time. However, with the ACS user interface, learning about a variable is as simple as right-clicking the value next to the variable you want to provide you with a dialog with more information and controls to edit the value. At the top on the right side of the user interface is another button showing the currently selected output module. Clicking this button will expose a drop-down list of available output modules. Selecting a different output module will change the items below the button to reflect the selected output. For example, we can select propulsion and view the data generated from ACS with a propulsion output module. Most of the output in the different modules is composed of various plots and their controls, but there is also a raw text viewer at the bottom of most output modules. If I place my mouse cursor over a point on a line plot, I will get data about what I'm hovering over. I can go back up to the top of the plotting key and enable or disable certain lines. If I left-click and drag on a plot, I will get a selection rectangle that when I release the mouse will zoom in on the area I selected. Likewise, a right click and drag on a plot will cause the plot to pan in the direction I drag my mouse. Clicking on the gears icon in the plot exposes a menu that contains the fine tune to display the plot along with the ability to print and save plots for external use. Changing the output to view the geometry will show a graphical representation of the geometry section. Note that changing a geometry value in the editor, such as wing sweep, automatically triggers the underlying analysis code to recalculate all outputs, including the geometry displayed. The toolbar at the top provides controls for manipulating the display of the geometry. Wireframe, transparent, and solid rendering can be displayed. It is also possible to pan and rotate the vehicle. This concludes the tour of AVID ACS 5.0. For more information, please contact AVID using the information provided in the description bar below. We will continue to provide informational and how-to videos demonstrating various AVID software products.